present, I do I do want to acknowledge a few people. First of all, thank you, to my immediate leader, Della Booth, for having the foresight to get us to plan something as wonderful as this. Thank you for having us be here. I also want to recognize Carla Raymond Kidd. She is our president-elect for USA 2020, the 2024. So she'll be coming on after 2023 as our leadership. So I wanted to acknowledge her. If you'd like to say something, Carla, please, how you have the floor. Della, you
Thank
also have the floor
you.
if you'd
Just
like
wanted to
to say
wish everyone
something.
a happy new year in person. It's great to be here with you all today. Philip, thank you for being our guest. Very much looking forward to the program today. And of course, a big kudos to Della and Dawn for putting this on today and organizing this. So again, thank you. I don't want to take up any more time. Dawn, the floor is back to you.
Thank you. Thank you. So Philip, tell us a little bit more about yourself, and then you have the floor to talk about your presentation and teach us all about the beauty of 3D printing around the world and what it's going to do as far as sustainable development for the future.
Sure. Thanks, Dawn, for the warm welcome. I'll try to live up to the expectation set forth, and thanks to the group as well for having me here today, and for everybody joining in. I'm always very excited about sharing in and disseminating knowledge really in the field of construction 3D printing, which is one of the hottest topics right now within housing and within construction in general. And that's really what I'm here today to speak about. So I think we will have around 45 minutes of me just blabbering, and then followed by some Q&A at the end. So thanks again for inviting me. And I guess, Dawn, I can just go ahead and share my screen right away, right?
You should be able to share your screen, and if you have any questions or problems with it, let us know, because we have the wonderful Allison who's here to kind of help us get through any technical issues that we might have.
Awesome. And I'm sharing here with audio as well, so I hope that you guys will be able to hear that too. Can you see the screen?
Yes, we can see the screen.
Okay, awesome. So title of today, and we're putting the bar high, you could say. So 3D printing is transforming the housing industry. And let's just talk about how that will happen. Before we get going with the agenda, I want to go through. I just want to briefly show you what it's all about. So simply just to set the stage. 3D printing in general is a way of automating the construction of buildings and other structures using concrete. So you can see here the layers being extruded of this concrete, which will give you the final structure. Even better than a photo is a video. So let me just go ahead and play a short video here. It might be a bit chubby since we're doing this online, but in essence, this is a 3-story building that was 3D printed by our investor Perry Group in Germany. You can see here these guys are looking at the 3D file, which then comes to life using this machine here, extruding the concrete. This building here is around 4,000 square feet. And you can see how the other contractors through the electrician come in and work in unison with the printer. This is the second story of the building. They're finishing up. The printer is finishing up. And then the third story. The roof is then put in via conventional method. By our investor and our client Perry Group in Germany. So really a fantastic project. So these are the 5 agenda points I want to go through. And number 1 is just a quick intro to Cobot. Number two, what are some example 3D printed structures done around the globe? We're a global company. Number three, I want to take you through what are some promises of 3D construction printing. What are the benefits in essence? Number four, simple steps of a 3D construction printing project. And then rounding up step 5 or agenda point 5 with future trends. After that, we can take the Q&A. So let me just jump right into a quick intro about Cobot. We are the world's largest manufacturer of 3D printers for the construction industry. So we have 3 regional offices. Myself, I'm from Copenhagen, Denmark. We have our offices in Miami, Florida. I just flew in yesterday, actually. So that's where I live with my team. We opened also last year an office in Malaysia to cover Asia Pacific. And then lastly, we plan to have an office open in Dubai in the coming year to cover the Middle East and Africa. We've had almost 100 employees, so growing quite rapidly. And we've sold around 65 of these systems on 6 continents. And already 1/3 of these are from repeat customers. So it really shows that the machinery is actually adding value, which is very nice. Moving on, Cobot does 3 things in general. Number 1 is we develop and manufacture and we sell these 3D construction printers worldwide. And they start from around $500,000 per system, such as the one you see there to the right, which was in Las Vegas last year. Now, we're not a construction company ourselves. So we sell the technology and then our clients, they actually do all the projects. But we only supply the printers, not the project execution. Secondly, we cooperate with these companies in bringing these projects to life. So there's a lot of support around actually getting these projects executed. So we do that with, for instance, GE, with Perry Group, Larsen & Toubro, which is India's 7th largest company, et cetera, et cetera. And then lastly, there's a lot of R&D that we do, both within materials, but also within the design and the structure of 3D construction printing, which is somewhat different from a conventional building. And we do this, for instance, with the largest cement and concrete companies in the world, such as Holcim and Cemex, and also a lot with universities. Here you can see our world-class investors that really enable Cobot to get this technology all around the globe and getting it used, really. And one of which is General Electric, Holcim, the world's #1 cement and concrete manufacturer, Cemex, which is, I believe, #6 in the world for supplying concrete and cement, and then Perry Group, who's a giant within conventional construction equipment, such as formwork and scaffolding. So really an A-team of investors, you could say. Here is a growing world map. You can see that we have sold especially a lot of machines in North and Latin America. And this is where we have our region with our regional research offices here in Miami, but also a very good presence around the globe. It's really being utilized not just in a specific area, in a specific industry, but instead in multiple industries on all continents, which you'll see in just a bit. And lastly, about Cobot is, of course, the most important part, which is our 3D printers. And here you can see that it consists really of 2 parts. One is the printer itself, and the other part is the concrete batch plant. That's the blue thing to the right, where you mix in the concrete on site. Now, the concrete then goes through the hose and gets extruded through the print head of the printer to the left. And we call this the Bot 2 because it's a 2nd generation Cobot printer. This is fully modular, which means that we can basically tailor the printer size to any kind of project that our client wants to do. I can just show you here how that looks. Fully modular, meaning we can extend the length, width, and also the height of the printer. And here you can see the blue bounding box, that's the print area, 3 stories. We can also simulate projects that our clients have done, which means we can take a project from the digital world, as you see here, to the physical world that you can actually live in. And if you thought this looked cool or want to try it out, you can go to our website and play around with this. It's a lot of fun. This was a short intro about Cobot, but what I think is even more exciting is actually how our clients, our partners, use this technology to change the world of construction. So that's the second thing I wanted to take you through here, a few example 3D printed homes and other structures. Just a quick overview, you can see here that our clients have really used this technology around the globe. From anything, from when we 3D printed the first home in Europe, which was in 2017, a small 500 square feet home, to 2-story buildings, 3-story buildings, schools in Africa, buildings in the US, office buildings, urban furniture, and I could go on. There are a lot of basements. There's a lot of different use cases for this technology, and it's only growing. So we saw a lot happening in 2022. I need to actually update this list, and we will see even more so in 2023 moving forward. If we deep dive on a few of them, we can start off here with a home that's now, it's actually now, I guess, almost 4 years old. It was done in Belgium. It's 1,000 square feet and it's done in 2 floors and 3D printed in just 21 days, which honestly, for a first project, that's actually quite decent, especially given it was in 2019. Let's just have a look at how that looked. So you can see here the machine does more or less all the work related to the raw house structure. And then afterwards, once the machine is done, you have the other contractors come in and finish the non-3D printed parts, such as the windows, the roof, the floors, kitchen, et cetera, et cetera. Let's have a look at another one. I find this one particularly beautiful, done in Germany a few years ago, 1,700 square feet and in 2 floors. They even 3D printed, which is quite cool, they 3D printed the bathtub as part of the outer walls, which is just a nice little touch. We've also seen kitchen islands being 3D printed. And the cool thing is you actually have a family living in this building. It's not just a demo unit, and this applies to a lot of these buildings that you'll see here in my presentation today. I see we have some comments in the chat. Fascinated, the design is amazing. I want this. Thanks a lot, guys. We like the support. This one here, 4,100 square feet. That's the one you saw in the initial video. And this one is a three-floor building, which took only 21 days. So they actually reduced the amount of time from the first to the second print by 15 days, despite doubling the size of the building and added an additional floor. Quite impressive by Perry Group here. And then again, you have families living in here. You actually have you have 5 apartments in this building. If we move on, I had to show you one also from my home country of Denmark. This was a student housing unit with fancy Scandinavian design, 1.5 floors, and it took them around a month to print. And they now plan to do an additional 20 of these for the local students in that small town of Denmark. So that's quite neat as well. Here's one a bit closer to us. So this one is in Ontario, Canada, and that's the world's largest building that was 3D printed using real concrete, 2,300 square feet. In Canada, it's a multiplex with 4 units, I believe. And then another one that we're very proud of, also by our client Perry, a 2-story building in Houston, the first 2-story building 3D printed in the States, and it's going to be larger than 4,000 square feet. And they did a short video, so let's just have a look. And installing the printer, which is also a good sized piece of equipment. The concrete gets extruded. And you can see here how the technology really allows for doing designs that would otherwise be way too complex and too costly to do with conventional construction methods. And these are the partners that are involved in this project by Perry Group. So quite nice use of the technology, and really once they're done in a few months with the 3D printing, I think it's going to be one of those like historical moments almost of this technology. You can also use it for other types of structures. So here we have some urban furniture 3D printed by our client in Guatemala called Progreso. And it's a bench for, I think, for a bus stop, and it just looks really neat with the combination of the light here and the concrete. For other types of structures as well, we also have this ginormous 33 feet tall wind turbine pedestal. The idea is that you 3D print these pedestals on site, and then you stack a regular steel turbine on top, meaning that you reach higher for stronger winds and more steadier winds, increasing the energy output. So this is something that we're developing together with our investor, General Electric, and they actually plan to 3D print these towers up to 6 or 7 stories in height, which is really staggering. This one here weighs, and this was the test unit, weighs around 100 tons of concrete. So imagine once they do these in 70 feet, it's going to be really a big one and help with the green transition, of course. I'm just going to skip the video here, just due to time considerations. So those were some example 3D printed structures, and I hope that gave you an idea as to how this technology can be used to really do construction in new ways. But besides it just looking awesome, I also wanted to talk about what are some of the benefits of this new technology. And we really see 4 main benefits of 3D construction printing. Number 1 is automation. Number 2 is speed. Number 3 is material efficiency or sustainability. And number 4 is the added design freedom. And today I want to deep dive on number 1, number 2, and number 3 here. So if we start off with automation, in essence, you reduce the labor cost by having less labor on site, which is especially hard to get these days due to a lack of skilled labor. And in addition, you increase the quality and the precision and the safety by having the machine do the work. So let's just talk a bit more about automation. If we look at the US housing market right now, you guys are all well aware that it's not looking too bright. There is around a 4 million home housing shortage in the States. The housing prices have increased drastically post-COVID, 30 to 40% by the records I could find. And the average construction time has also almost doubled from 4 to 6 months to 8 months plus here post-COVID. That's why we want to introduce this technology to really address these issues created. Now, automation is truly needed in construction, in the housing market. Construction is the world's largest industry. However, it's one of the least automated industries as well. If we look at the productivity gains across a few sectors in the States from the 1950s to 2010, we can see that agriculture improved 16-fold, manufacturing increased almost 9-fold in productivity, whereas construction, you have to go all the way there to the bottom, it increased by around 1.1 in a 50-year time span. So it barely moved the needle. And one of these reasons is a lack of automation, which the other industries have seen, but not to the same extent in construction. In addition, you have a global shortage of skilled labor, as mentioned before, meaning projects get postponed, and coupled with a worldwide increase in materials such as stick frame, so timber and steel is a dangerous cocktail, you could say, and it's especially not good for future home owners. That's why we introduced this technology. And we've already seen now that by some of our clients, despite the industry being very nascent, they have actually claimed that they have reduced the cost of their buildings. Here is one in Virginia, done together with Habitat for Humanity, the NGO, and our client, Allquist 3D, 1,200 square feet. And they mentioned that they reduced the cost by around 15% versus doing it stick frame. While we haven't looked into those numbers, we have started to hear anecdotes that the costs are actually coming down. And I see this only improving for the future. Remember, we only sold the first machine in 2019. And imagine where we're going to be then in 10 years from now. It's really looking bright moving forward. The same, another example of reduced cost is this 3D printed school done in Malawi, Africa by our investor Holcim. Here it's covered by the World Economic Forum. They claimed a 50% smaller carbon footprint, and then they 3D printed it in only 18 hours with both an indoor and outdoor classroom. They have started now a very large-scale project with 50 homes in Kenya, Africa as well. So we're going to see more and more of these projects popping up. Let me just check the chat here to see if there are any questions or otherwise.
We have questions. We have a lot of questions, Philip. I actually was going to wait until the end to kind of go through the questions, unless you want to stop right now and answer questions.
Let's take it at the Q&A, and then if there are any follow-ups, then I can take them right away.
Okay, because Della and I are kind of collecting them, so just to make sure that we get them all.
Cool. Sure. Okay, thanks.
You want me to start, Dawn? So the
one of
the questions was, are these types of structures approved in all 50 states? I know you're on the manufacturing of the equipment end instead of the building end, but do you know if they have structural approval?
Actually, let me, if it suits you guys, we can do the questions at the end, at the Q&A, and then I'd be happy to speak more about permitting and all the rest, if that's okay.
That's good. That's good.
Okay, awesome. But we can for sure speak to that. So the second benefit of 3D construction printing is speed. Being able to do homes faster. Faster execution means faster or bigger returns. So as an example of this, we have one here of Cobot doing the same 3D printed building twice, actually. We built the first 3D printed building in Europe back in 2017, around 500 square feet. And it took 2 months to print, which, you know, for 3D printing a new building, this had never been done before on that continent, we thought that was fairly okay. But then 2 years later, we actually replicated the same building using the same 3D file. And we went from 2 months down to just 3 days. So that's a productivity improvement of a factor of 20. And you can just have a look here how it looked the second time that we did it. And everything is documented. That's why we had the clock there in the front, because we want to be very transparent about the claims that we have. In this video here, you can also see over how many days the building was 3D printed. So a telltale of that is the color changes. So the bottom half has sort of a lighter color, which is the first day where the concrete is cured. And then on top, that's the fresh concrete being extruded there in the back. And here from the top with some more stats. So this was done, this was a productivity improvement of around 20x. And we see this all the time with our clients, that the learning curve is so steep that from they do the first project to the second to the third, they improve drastically, both with regards to speed, material waste gets reduced also by a lot. It looks better, et cetera, et cetera. And I think in 5 years, 10 years, this will be a major competitive technology to conventional methods. And it already is today by the anecdotes we hear, and it'll only improve from here. It's really fascinating to see what our partners do and accomplish using the 3D print technology. So speed was benefit number 2. And the last benefit I wanted to talk about was material efficiency. So reducing waste by only 3D printing what you need. And then secondly, you have the possibility to do new and greener kinds of materials. If we just jump into one, which I find particularly fascinating, is reducing the amount of material used by optimizing the structure. So as an example here, we have 2 classroom designs that our client wanted us to do some renderings of. One is a modern one with rounded, you got 3 rounded classrooms, which is kind of unconventional compared to the bottom one, which is exactly conventional in that it's 3 rectangles next to each other, a room that we've all been in before. If you look at the stats here, you can see that the floor area is the same across the 2 designs, 2,200 square feet. But the material usage of the modern design is actually 10% less, simply because a rounded shape is a more efficient shape than a rectangle. So 10% less material by just doing a different design. In addition to that, I also find that the modern design is more aesthetically pleasing. And also it's honestly, it's better suited for learning because of acoustics. Everybody is facing the teacher at the middle of the room, similar to one, you could say, an old Greek auditorium or theater, where people would be facing sort of inwards with the actors at the bottom of that theater. So material waste reduction through a different kind of design of the buildings. Here's how that would look if you put it all together with 6 classroom designs. And it just looks way more interesting than a conventional schoolyard, at least the schools I've seen around the globe and the one I went to in Denmark. Lastly, I said I wouldn't talk about it, but I just bonus round here. The design freedom you get from 3D construction printing is out of this world. It allows you to do designs that you would have otherwise never done, such as the 3D printed wave pattern you have here. Or if you see now coming up here in the front, you could even do a logo where you imprint, in this case, the Cobot logo right into the walls themselves. which would be at the same cost as doing these walls in a straight line. Let's just do it, let's just have a look one more time. Really, really pleasing to the eye. So those are the 4 benefits that we see of 3D construction printing: automation, speed, material efficiency or sustainability, and 4, design freedom. Here, I wanted to talk about what are some steps of a 3D construction print project. I will not go through all of them, but just to give you a high-level introduction to it and answer some of the most common questions we get within this area. So if we have a look here, high level, you would need around 4 people on the 3D construction site. So you have a print operator. That person is all the way there at the top, sort of overlooking the print area. Secondly, you would have a materials expert standing next to the concrete batch plant, which you see there in the middle, outlined in blue. 3, you would have a materials helper. So this person is in essence refilling concrete or the components of concrete, sand, cement, and gravel into the silos, and then that's mixed together to create concrete on site. And then fourthly, you might have a visual inspector or helper simply to walk around and ensure that the walls are coming out as intended in the 3D file. So this is a typical overview, and you would reach around 3 or 4 on site within a few projects. Initially, you might need a few more as you get accustomed to the tech. We see 7 main steps of a 3D construction site. You have 3 groups: the initial manual work, 3D printing, and finishing. So step 1 is excavating the ground. Step 2, installing the Bot 2 3D printer. Then the fun starts with step 3, which is printing the top foundation of the slab. Then step 4, printing the walls. Step 5, completing any horizontal work. This could, for instance, be 3D printing the roof or 3D printing the slabs for each floor. And then lastly, finishing, step 6, post-print finishing. It might be that you want to trowel the walls to do smooth walls, adding insulation, MEP in general, and then disassembling the Bot 2 and moving it to the next construction site. If we just deep dive here on the middle part of the 3D printing part, we can see here how the initial setup of the printer requires the operator to do a dry run. We call it a dry run when there's no material being extruded. So here what they've done is to lay out the pattern that the 3D printer will follow. So it's actually going around on top of these pieces of wood to ensure that the print head that you see there in the red circle actually will go on top of the slab and not into the dirt around it. So this is just a good way of really just making sure that you're not going outside of the boundaries. The question we get often is how we do reinforcement, and this is also related to the permitting question we had before. So in essence, if you look there to the left, what we do is around the interior or exterior walls, we 3D print these columns that are then, what you do once the columns are finished, you stick down the rebar, the steel, and then you backfill with regular concrete. And then those become your load-bearing elements of the structure. So typically that's how you get the permitting done, not through the 3D printed walls. They're more, you could say, ornamental, despite them being very, very strong. And then what you really get permitted are those columns with regular concrete that's backfilled and reinforced with steel here. To the right, you can see how electrical sockets are done. So when you do the print, basically you simply just stick in these styrofoam cups or other types of cups that the printer then print right on top of. And then once the concrete is cured, you can pull them out. The electrician can come in and run the conduit and everything else. So it makes it actually easier for other contractors to come in and do the work. You can see here how an electrician at this point will actually be able to come in and run the conduit at knee height, right? Which might be more difficult using or with conventional construction methods. So these were just some of the steps. Obviously, there are many, many more steps to 3D printing at home, but it does make home construction significantly easier. And now in the last 5 minutes, a few points on future trends of this technology. I hope until now you've seen how this technology can really be a major unlock of productivity and all the other benefits mentioned for construction and really be a transformational force in the construction industry. And I think these future trends will only take that trend further in the future. So we see 4 major trends. Number 1 is that we're going to go from one-off demo projects to multi-unit 3D print projects. One example is this home project here in Kenya, in Africa, 50 affordable homes that they plan to do using 3D printing, and they have actually done around 8 of them already. This will be published at a later stage. And we're going to see only more of these projects being done also in the States. Our clients are doing more and more projects, more and more homes, increasing the volumes, which is further reducing the costs and the speed, sorry, and the timing for each project. Secondly, we're going to see much, much larger printers, and Cobot wants to be a driving force of this. So the printer and the projects you've seen so far have been the Bot 2. That's the small printer that you see there at the bottom, which if you looked at the video, it's not a small piece of equipment by any means. It's 40 feet tall, right? 30 feet tall. So can print up to 3 stories. But the printer you see there in the back, which we have developed and delivered already to General Electric, the largest in the world, that one can print up to almost 70 feet in height. That's around 6-story buildings. And this is really going to take construction 3D printing to the next level by allowing us to do more projects. And you can see these are not just renderings, right? They're actually out there in the wild. One of which is around 90 feet in the length, which we delivered to the Middle East. And the one to the right, which was a prototype, which later became the Bot XL, which can print up to almost 70 feet in height. Really fantastic work by our engineers and GE, whom we work with to accomplish this. Trend number 3 is that we're going to go from these machines being just 3D printers to really becoming multifunctional construction robots. So they would have more than just one purpose. Right now, what you've seen is the shell of the building being 3D printed, the raw house structure. But these machines, now that they're up there, why not allow them to do even more features, add more features to them, accomplishing more and more tasks on a construction site? This could be, for instance, it could be sanding down the walls. It could be pouring insulation in between the walls to reduce the cost of that. It could have a, let's say, a spray gun attached, so you could do spray painting off the walls. There are simply so many features that we could develop and we could stick onto this type of equipment that have yet to be explored. And we have already started. As an example here, this is a photo I took in New York, in Bergen, last year during the introduction of GE's new facility. So they have around 15, 20 people working in this GE facility in New York to develop these wind turbine towers. And you can see the multi-functionality at play here. In the front, you have the print head for distributing concrete, as you've seen before. for building these turbine towers that we discussed. In the back, however, you have actually a secondary x-axis in the width. And on that, you have a tool for picking and placing reinforcement on top of these 3D printed turbine pedestals. This is just one example of multifunctionality, and we're going to add more and more features to our printers moving forward, which will only help reduce costs further, improve speed, and make it more sustainable. So the best is ahead for this technology. This was the conclusion to my main presentation. Thanks again for listening in. I hope that this was an inspiration as to how 3D printing is transforming the housing industry. And now I'm happy to take any questions from the audience.
Wow, thank you so much, Philip. That was amazing. I want at least 3 of those houses in one of those buildings myself, especially the one that you call beautiful. It was really, really nice. So we have a few questions. Della, did you want to tag team on the questions, or did you want to just?
We'll start at the top and we'll see how many we make it through. Okay.
Yes.
So
okay.
Again, the conversation about with this type of structure, I mean, you live in Miami, you know, Florida's got special building codes. So like how many states in the United States has this type of building process been approved?
It has only been approved actually in a few states on you could say on a statewide level. What typically happens instead, and I do believe that in a few years we will see more and more states approving of this kind of build method. But because it is very new, it's very typical that the technology is faster than regulation. Yes. Regulation typically trails new technology by a few years. What our clients do is that they know much more about local permitting than we could ever do. So they work with local structural engineers and local architects who know that the permitting process and know the regulation. And then they come to us with that, and then we discuss, okay, how can we 3D print to accomplish and to get the approval of those local permitting boards. One example being these 3D printed columns that you saw before. Most of our clients actually follow that process, and so far that has not stalled their operations by a lot, and it is getting more and more easy as they see this technology being used more and more frequently.
Excellent. Do you know if there is what's the typical cost savings per square foot? And are you comparing that to a stick built or to a concrete block built home?
It's a very good question, and it's probably the question I get the most. I get it around 10, 15 times per day. Cobot is very hesitant with regards to these claims about cost savings. Right. And the reason is we still lack good general data across the world where we can truly say, okay, these are the general cost savings, or this is how much time you save. Okay. So far, what we do is we refer to our clients, such as Allquist 3D from Virginia, who mentioned that they saved around 15% versus stick frame, or the school that you saw being constructed in Africa. I do, however, because we hear it so frequently that they're saving time or they're saving money, I do believe that right now it might be on par with conventional construction, maybe a bit more expensive for the first project. But as you do more and more projects, the cost will definitely come down. And the technology is so new that imagine in 5 years, in 10 years from now, we're going to go even lower, because conventional construction has existed for hundreds and hundreds of years. So it's almost not even fair to compare that to a technology which, we sold the first printer back in 2019.
Right, totally agree. So as far as plans, building plans, house plans, can you take any floor plan and convert it to a 3D printing, or does it have to have special nuances?
For the most part, yeah, we can take any floor plan and convert it to 3D printing. it happens quite frequently that new customers, they come to us with their blueprints for a conventional, let's say a stick frame home, which is very common here in the States. And then we discuss with them how we can accomplish this using 3D printing. And yes, that might mean changing a few things, but typically only for the better. So whereas you would typically have a stick frame home being a rectangle or a square, almost a bit boring, you could say. Now you can unlock these rounded shapes or 3D printing a kitchen island, 3D printing a bathtub, which is, in my opinion, way more interesting and also cheaper compared to conventional methods.
Yes, I totally agree. So does the printer use standard concrete or does it have to have a special mix?
There are two ways of going about 3D construction printing when it comes to materials. And I want to compare it to baking a cake, which also has two main ways. If you want to bake a cake, you can either go to Whole Foods or Trader Joe's, whatever, and get your own, I'm not sure what you call it here in the States, like Easy Bake, right? So you get a mix, which is pre-made for you. You add water, you put it in the oven. It's the same with 3D construction printing. There are what we call a dry mix mortar, where you receive the dry mix and you just add water to it, and then you can start 3D printing. So that's one way. The other way, if you want to bake a cake, is you buy the flours, eggs, what else? I don't do too many cakes, sugar, and then you mix it together, right? And that's the same that you can do with 3D construction printing, in that you mix your own concrete on site with locally sourced materials, sand, cement, gravel, and water. That's how you do concrete. Now, the benefit of doing it locally is that you reduce the cost by big amounts. Secondly, it's better suited. It's more easy to adjust the concrete according to local temperature changes. And then thirdly, it's better for the environment because now you're sourcing local materials, which are quite heavy, instead of, say, having it procured from one central location where it's manufactured in the States.
Okay. Can the printer use other materials besides concrete?
It can, and we have an open source material strategy. So while we haven't seen it yet, we have a lot of clients that want to experiment with adding other types of components to the mix. Many of them have talked about doing hempcrete, so using hemp fibers in the mix. Some have talked about adding graphene to the mix for increased strength. And then lastly, which we've already seen, is many of them would add polypropylene, I think that's the word, fibers, angel hair fibers to the mix, which reduce surface cracking. So it's an open source strategy and mindset we've had from the beginning that we want our clients to experiment as much as possible. We don't want to lock them in to any kind of mix and then overcharge them for that. No, they should mix it locally and test like crazy.
Very interesting. So have any of your builders talked about the efficiencies in the living environment, such as heating and cooling?
Sure. And I want to bring up one thing here, which is insulation. So concrete homes are typically quite well insulated, and it only helps to do the 3D printed buildings, in which you have, for the most buildings you saw here, you had an exterior wall and an interior wall. In between those walls, even if you don't add insulation, there'll be air trapped, and that air helps with insulating the building. But most clients, they add insulation in between. Say they add mineral wool, any kind of bats or spray foam in between the walls, which further improves the insulation of the homes and reduce the ongoing cost of heating or cooling that building.
Excellent. Okay, so here's an interesting one. What are the challenges to building on a not flat surface, like, for example, a hillside? Is that something you could accomplish?
Yes, that can actually be accomplished. And instead of me trying to explain that with words, I can instead show you a rendering of how that's accomplished here in our. I would call this. I'm just going to share my screen here again. I would call this our Bible almost, our Bible of 3D printing. This is a document. It's called a design manual that goes through all steps from planning to printing of 3D construction printing. So here are all the steps that it takes us through, and one of which is the installation of the printer. You can see here are some of the steps that I mentioned before as well. If we just go through here, and then I can sort of zoom in here at the bottom, and you might be able to see here, if there is a slope, we can actually adjust the x-axis or the width where the concrete gets extruded of that machine accordingly, simply because one of the C-towers, one of the columns of the printer will simply be higher than the other. But then you could sort of level it there in the middle according to how steep that slope is. So I hope that makes sense to whomever asked that question.
Yeah. Do your global corporations and partners consult on projects?
Yes, they do. So imagine, I'll give you an example here. I hope I answer this and understand this question correctly. One of our clients in California called Emergent 3D, they have now finished around 4 homes, I believe. And it's very common that either they receive inquiries from local California residents that are interested in having buildings done, or by developers, or that we receive them and then we forward it to Emergent, who would then give input as to how that project could be accomplished.
Okay, very good. So where are the machines actually made? And how long does it take to manufacture them?
The machines are made in my hometown of Copenhagen, Denmark, by my skilled colleagues, and then they're shipped all around the globe. However, we are investigating potentially setting up manufacturing here in the States as well. It won't be this year, but down the line, that could for sure be of interest. The production of the machines right now, we aim to get that down back to around 4 months again. We have been hit a bit hard by supply chain issues, like any other industry, especially the manufacturing industry. But we want to get it down into the 4 months range of production.
Very good. And so there was several comments about how hard it would be to find that 4-person team that works, and what the training processes would be to establish a 4-person team.
Sure thing. And in general, this is one of the, you could say, obstacles of 3D construction printing. So permitting is one, as we mentioned before, that regulators need to get up to speed with this new technology. And secondly, upskilling of the labor force is also needed. So right now, what we do, we try to hold our clients' hands as much as possible, because we understand that it's new technology and it's a very uncommon build method that not many people have actually done. So we have online training before the client has received the printer. Then we have a week or 2 of on-site training, where we take them through anything from installation to mixing of concrete to troubleshooting, printing the files, et cetera, and then lastly we have subsequent servicing and support 24/7 to help them out. But it will be a major transition in the construction labor force to train all of these people so that they can use this technology. And the good thing about that is that hopefully this training will then also drive up the skill level and wages accordingly.
Absolutely. Is there a percentage of error that the printer has? How exact is it? Is it like working on a CAD system, right? You set it up, it works.
Yeah, it's not plug and play, if that's what's meant here. This is one of the common myths of 3D construction printing, is that you simply plug it in and then you could print any type of home. And sometimes that's how the media portrays it, which is a bit of a shame because we really don't want to disappoint any client, which is why we're very transparent with regards to what's possible and what's not. So you need the training, you need the right crew, and you will go through issues as you learn. But again, the learning curve is super steep. I typically compare it to learning how to ride a bike. Initially, you might have your parents behind you with a stick sort of to steer the way. You will fall while learning it, biking, not 3D printing, hopefully. But with time you can maybe ride with one hand or even with no hands. And it's very quick, this process. So one example, our client again in California, when they 3D printed the first home, it took around, I think, 3 weeks, something like that. But the second home they were much faster. They got it down to around 10 days. And then the third home and the fourth home. Imagine once they do their 50th home, learning how to ride a bike. That's how I would describe it.
Excellent. Well, I have 3 more questions if you can bear with us. Okay,
Sure
so
thing.
how environmentally friendly is the production using concrete versus standard production?
So we are actually quite interested in this topic and are investigating it quite heavily. What we're looking for is comparing a 3D printed building with, say, a stick frame building. And you want to compare what are the greenhouse gas emissions from both buildings. And those numbers you can actually find. However, you can't find any good numbers that compare the at least we haven't been able to so far, the longevity of a concrete building versus a stick frame building. Because obviously, if you have a stick frame building and a concrete building that while manufactured, they use the same amount of greenhouse gases. If the concrete building lasts for 3 times as long as the stick frame building, that would be more environmentally friendly than the stick frame building. So this is something we're looking into. But again, we always want to be very transparent and we want to have the right numbers before we claim anything. So I can't really say anything for sure right now, but definitely, I mean, I could refer you to the conversation or the presentation I had where I talked about how it reduces waste by only 3D printing what you need and allows you to do new kinds of greener materials to further reduce the greenhouse gas emissions.
Yeah, exactly. Okay, and getting close to the end, lifespan of the BOD.
Good question, because we sold the first printer in 2019, so we expect them to last, I would say, at least 5 years, but maybe they could go up to 10 years. The printer is similar to that of a crane. If you look at it, the columns almost looks a bit like what you would have on a typical crane, and typically cranes are depreciated over a 15-year time span. The majority of the machine, the 3D printer, is a strong galvanized steel, which that's not going anywhere. Of course, you might have some replacements of electronics or gaskets or otherwise along the way, but those aren't that expensive either. So we expect quite a good lifespan. Check back with me in 5 years and I have a better answer.
Exactly. And then we did have a question about what the cost was. I think there were several people that joined after the program had already started, so I think they missed that at the very first.
Sure. So our machines, and this is a turnkey solution. So you get 3 things. You get the printer, you get the batch plant where you mix the concrete, and you get the training. If you have one of the smaller printers, which could do, say, the tiny house that was done in Denmark, that kind of size, you would be starting for the turnkey solution at around $500,000. Then we have the very large scale printers, such as the one delivered to GE. And that for the printer alone would be around, I would say, $1.2 million.
Okay. Okay. presentation was fabulous. Thank you very much. That's all the questions we have.
I have
Thanks.
one question myself. And it actually goes along with the question that somebody, I don't know if you asked this when I didn't hear it, but they were asking if COBOD has printing plans for commercial housing. Do you have like house plans or commercial building plans that you have that are standard that the printer can use as a turnkey situation?
Very good question, because I just came out of a meeting with my Danish colleagues around this a few hours ago. Yes, there are two sides to the coin. Number one, right now we do have common homes, standard test homes that you would typically print as part of the training as our clients receive the machine. And they can, of course, be adjusted to the local customer and what they wish. But as a second thing, we are considering selling or developing these types of standard home packages where you would get a common home, beautiful, 3D printable, 1, 2, or 3 stories, and which then can be adjusted according to how you want your building to be designed, and then 3D printed by either yourself or a cobot operator in the States or elsewhere. So this is something we're looking into.
So I just want to say thank you. You were amazing. The presentation was absolutely wonderful. I learned a lot. I'm even more intrigued than I was about 3D printing. I've been a 3D printing kind of fan for a few years now, just waiting for the good stuff to start. And I'm really happy to have been able to have you come and educate us on the process and the different ways that it's being used around the world. I am ecstatic with just what has happened. So thank you so much for being here, Philip. We appreciate you. FIABCI USA, we do appreciate you.
Sure thing. Thanks for inviting me, and thanks for a very good Q&A session. I hope you will hear only more about 3D construction printing in the future, and this was just a small glimpse of what is to come. So thanks again for inviting me, and yeah, I look forward to bringing out more news about this technology moving forward.
Absolutely, it was fabulous.
Thanks again,
Oh,
Philip. Really appreciate that. And if you can make sure someone has your contact information, as some people were asking for, we could send it out. And on an aside, we'd love to see you become a member of FIABCI. I think,
oh my God, yes.
I was going to have that conversation with them.
All right.
Are you in Italy yet?
We don't have any clients in Italy yet. We do have a good presence in Europe. I was also invited. You guys must be at what's the housing conference in Cannes, France?
MIPIM.
Yeah. I was there last year presenting as well. So we
Will
do
you be
try
there
to sort
this
of
year?
You'll be at MIPIM this year?
I don't think I will, because I mean I'm flying way too much back and forth between Miami and Europe. But one of my colleagues might drop by.
Well, you know, Philip, I hope you do become a member. I'm jumping in and hijacking because we're going to be in Miami for our. I don't know if you are aware of that, for FIABCI. We'll be there in, what is it, June, ladies and gentlemen? June.
Yeah, June 5th through the 9th
we'll
is
be
our
there,
World
June.
Congress.
Wouldn't that
Yes.
be great? Wouldn't that be
It would be
absolutely
amazing.
Yeah.
Awesome. I mean, if you could send a follow-up email and we can take it from there. And if I'm here in June, I might be back home with family and friends for the summer in Denmark. But if I'm here, we're also happy to give you a tour of our research facilities and everything.
Wonderful.
So you can see it in person. So
That
it's
would be
a bit
great.
more interesting than seeing my PowerPoint presentation.
Philip, this
That's
is Shirley.
awesome.
I just have a quick question. You mentioned you were opening an office in UAE.
Yep.
Okay, so are you going to be presenting anything at the International Property Show next month?
Not that I have heard of. No, I don't believe so. The UAE office in Dubai is, I would say, 1 or 2 years down the line. So we don't have we do have a lot of clients there, we don't have the office yet.
Okay.
So all the information I'm gonna get you about FIABC, about the COBOD becoming a part of FIABC if possible. And I'm gonna get right up on you as much as I possibly can. We'll get you invited to something in Miami. And if you're not available, maybe someone else can give us the tour while we're there. But I am so super excited and very, very happy that you came to spend time with us. Ladies, you guys, anyone have any more questions before we let him get back to his very important work?
No, I just
No,
want to make
just
sure Allison's
kudos
picking up on
to
that.
Dawn.
So while she's still on here, Allison, if you're still on, just take note about that tour in Miami. If we can work on that for
Yeah.
World Congress, that would be great.
Oh,
And
yes,
Dawn,
yes, yes,
amazing
yes.
job, honey. You did a great job. This is a beautiful,
Absolutely.
wonderful. I mean, I'm in Italy right now and I'm looking, oh my God, there would be so much use for this
Yes.
here.
Yeah.
Around the world.
So
Yes.
absolutely amazing. Thank
Appreciate
you
it.
all.
Thanks again,
Thank you,
everybody.
Dawn.
Thank you,
Have
guys.
a wonderful
Thank
day,
you, Dawn.
everybody.
Good job.
Take care.
Bye-bye.
Bye.